Pluto, a celestial dwarf residing in the distant Kuiper belt, is a world shrouded in perpetual twilight. This twilight is not like the one we experience on Earth, where the sun dips below the horizon, casting a brief, beautiful glow. Instead, Pluto's twilight is a constant state, a dimness that never quite fades into night nor brightens into day. Its immense distance from the sun dictates the amount of light that graces its surface. The sun, which is the source of all life and energy on Earth, is reduced to a tiny distant star from Pluto's perspective. Imagine a world where the sun, our familiar star, appears as a mere pinprick in the sky. This is not just a poetic description but a stark reality for Pluto. This is the reality of Pluto. The sun's light, which takes about 8 minutes to reach Earth, takes over 5 hours to reach Pluto. By the time it arrives, it is but a whisper of its former self. Pluto's distance from the sun is staggering. It orbits at an average distance of about 3.7 billion miles, or roughly 5.9 billion kilometers, from the sun. It's about 40 times farther away from the sun than Earth is. To put this into perspective, if Earth were the size of a marble, Pluto would be a tiny speck of dust, far, far away. At this distance, sunlight has lost most of its strength. The light that does reach Pluto is about 1,600 times dimmer than the sunlight we experience on Earth. The result is a dimly lit world, forever bathed in a soft, ethereal glow. This faint light creates an otherworldly landscape where shadows are long and the horizon is always tinged with a mysterious bluish hue. Pluto's surface is a fascinating mix of ice and rock, with vast plains, towering mountains, and deep valleys. The ice is primarily made of nitrogen, methane, and carbon monoxide, which gives Pluto its unique reflective quality. Despite its distance from the sun, Pluto has a thin atmosphere composed mostly of nitrogen, with traces of methane and carbon monoxide. This atmosphere expands when Pluto is closer to the sun, and contracts as it moves further away in its elliptical orbit. Pluto's orbit is highly elliptical, meaning its distance from the sun varies significantly. At its closest, or perihelion, Pluto is about 2.7 billion miles from the sun. At its farthest, or aphelion, it is about 4.6 billion miles away. In 2015, NASA's New Horizons mission gave us our first close-up look at Pluto, revealing a world more complex and dynamic than we ever imagined. The data collected continues to provide insights into this distant twilight world. From its heart-shaped Tombaugh Regio to its towering ice mountains, Pluto is a testament to the wonders that await us in the far reaches of our solar system. It reminds us that even in the dimmest corners of space there is beauty and mystery to be discovered. The amount of sunlight that reaches Pluto is a mere fraction of what we experience on Earth. Imagine standing on the surface of this distant dwarf planet, where the sun appears as just a tiny bright dot in the sky. The sunlight that does reach Pluto is incredibly faint, almost like twilight on Earth, but even dimmer. To be precise, Pluto receives about 1/1600th of the sunlight that bathes our planet. This drastic difference is due to Pluto's vast distance from the sun, which is about 3.7 billion miles away. At such a distance, the sun's rays are spread out and weakened, making the sunlight on Pluto incredibly sparse. This means that if we could stand on the surface of Pluto, the sun would appear significantly smaller and dimmer. It would be about the size of a star as seen from Earth, providing just enough light to distinguish day from night, but not enough to illuminate the landscape brightly. To put this into perspective, imagine dimming a light bulb until it's barely visible. The light would be so faint that it would struggle to light up a room, casting only the weakest of glows. This is similar to the experience on Pluto, where the sunlight is so weak that it barely lights up the surface. This is roughly equivalent to the intensity of sunlight on Pluto. The landscape would be bathed in a perpetual twilight, with long shadows and a dim, eerie glow. The faint sunlight would create an otherworldly atmosphere, unlike anything we experience on Earth. It's enough light to cast shadows, but not enough to create the kind of bright daylight we're accustomed to. The shadows on Pluto would be long and faint, barely distinguishable from the surrounding darkness. This dim lighting would make it difficult to see details and navigate the terrain, adding to the challenges of exploring this distant world. The best way to understand Pluto's daylight is to think of twilight on Earth. Imagine the period just after sunset, or just before sunrise, when the sky is still illuminated, but the sun is below the horizon. This is the kind of light that bathes Pluto's surface throughout its day. During this Plutonian twilight, the landscape would be cast in long, eerie shadows. The faint sunlight would create a surreal and otherworldly ambiance. It's a world where day and night are not so easily defined. Despite its distance and dimness, the sun would still be the brightest object in Pluto's sky. From Pluto, the sun appears as a tiny, brilliant point of light, much smaller than how we see it from Earth. Yet it remains the most dominant feature in the sky, outshining all other celestial bodies. This tiny dot of light is a reminder of the immense power and influence the sun holds over our solar system. Even though it appears much smaller than from Earth, the sun would still be a point of intense light, outshining all other stars. The sun's light travels over 3.6 billion miles to reach Pluto, yet it remains a beacon of brightness. This journey of light takes about 5.5 hours, a testament to the vast distances in our solar system. Despite this, the sun's brilliance is undiminished, a constant source of light and energy. To get an idea of how bright the sun would appear, imagine a full moon on Earth. The full moon is one of the brightest objects in our night sky, casting a gentle glow that illuminates the landscape. Now picture that brightness multiplied many times over. The sun on Pluto would be about 250 times brighter than that. This comparison helps us understand the sheer intensity of the sun's light, even at such a great distance. The sun on Pluto would be about 250 times brighter than that. This incredible brightness is due to the sun's immense energy output, which spreads across the vast expanse of space. Even though Pluto is on the outer edges of our solar system, the sun's light reaches it with enough intensity to outshine everything else in the sky. This phenomenon highlights the sun's role as the central powerhouse of our solar system. It's a testament to the sun's power that even from billions of miles away, it can still illuminate a distant world. The sun's energy is not just confined to the inner planets, it extends far beyond, reaching the outermost regions of our solar system. This illumination allows us to see and study distant worlds like Pluto, providing valuable insights into their composition and behavior. The sun's influence is truly far-reaching, a constant presence in the vastness of space. Section 5. The Blackest Night. When we talk about night on Pluto, we're talking about true darkness. Unlike Earth, which experiences varying degrees of darkness due to atmospheric scattering, Pluto's night is absolute. This is because Pluto has an extremely thin atmosphere. On Earth, our atmosphere scatters sunlight even after the sun has set. This is what creates twilight and prevents our night sky from being completely black. On Pluto, there's almost no atmosphere to speak of. So once the sun dips below the horizon, darkness descends immediately and completely. Section 6. Eyes in the Plutonian gloom. If humans were to visit Pluto, our eyes would need time to adjust to the dim lighting conditions. Just like our eyes adapt to darkness here on Earth, they would eventually adapt to the Twilight World of Pluto. Our pupils would dilate, allowing more light to enter our eyes. Over time, our eyes would become more sensitive to the faint light, allowing us to navigate Pluto's landscape. It would be a fascinating experience to see how our vision adapts to such an extreme environment. Section 7. Pluto Time. Pluto's rotation is much slower than Earth's. One full day on Pluto from sunrise to sunset takes about 6.4 Earth days. This means that a single night on Pluto lasts for more than 3 Earth days. If you were standing on Pluto's surface, you would experience an incredibly long twilight period, followed by an even longer night of absolute darkness. It's a completely different experience of time compared to what we're used to. Section 8. Earthly comparisons. To better understand Pluto's light levels, let's consider some earthly comparisons. Imagine standing outside on a clear night, far from any city lights. The only illumination comes from the stars and perhaps a sliver of the moon. This level of darkness is probably the closest we can get to experiencing Pluto's dim lighting. While it's not perfectly analogous, it gives us a sense of how faint the light is on this distant world. Section 9. A new perspective. Exploring Pluto's twilight world allows us to see our solar system from a new perspective. It reminds us that light, which we often take for granted, is a precious resource that varies greatly across our cosmic neighborhood. As we continue to explore the universe, we'll undoubtedly encounter even more extreme environments, each with its own unique lighting conditions. Pluto serves as a reminder that there's still much to learn and discover about the vast and awe-inspiring cosmos we inhabit.